Okay, so hi everyone. Today we'll be entering into the second learning outcome of your topic 5, which is the normal distribution. So today will be the lecture 3, meaning like the lesson 3 of this lesson. Okay, so for today's lesson, right, we'll be learning the same thing. You also need to learn how to use the normal distribution table, but today we'll be going into the part where you need to modeling your random variable, and you also will learn how to solve your problems concerning a variable x that if the x is normally distributed, then you need to learn how to find the probability and also how to find the k or the x if given the probability. Okay, so it's basically like before this lesson 1 and 2, you are learning how to find the probability or how to find the z with the given probability if it's given in the standard form. So today we are trying to apply it into like a life situation, because you see there's no distribution in the real world that actually always have a mean of 0 and a variance of 1. So that's why today we'll learn how to modeling and how to do standardization. Okay, so for today's lesson, the thing that is very important is you need to know how to standardizing a normal distribution and how to modeling a normal distribution. Okay, so it's going to be quite easy. So for the front part, I'm going to do some very quick recap and some explanation like why are we doing so. But if you can't, I will try to suggest you to really understand why are you doing so, because the formula will not be given in your exam also. Okay, so you try to understand why are you doing so, then after that try to learn how to apply. So if you think that the understanding part is a little bit difficult for you at first, then it's okay, you can try to go through you can try to learn how to apply first. So how to, like, you know, every new thing that you learn actually come from imitation. So just try to like imitate first, then after that when you get use of it, then after that you will try to understand it better. Okay, so some recap. Before this, you already learned what is a standard normal distribution. You also learn what is a normal distribution also. So basically the characteristic you have is like it's going to be a bell shape. It's symmetrical left and right when I draw a single peak in the center, where the center will be the mean, the median, and the mode. So for lesson 2, we also learned that the percentage, I hope you still remember, like 34 like around 68% of your data will be under the region that is like 1 standard deviation for your mean. Then after that it's going to be another percentage and so on. Okay, so the area under the curve basically meaning your probability. Okay, so in the last lesson or the first lesson, we mentioned that actually all normal distribution can be modeled by using a standard normal distribution. So today we are talking about how are we going to do that. Okay, so these are the notes. You can try to go through yourself, but I'm going to explain it with like graphic representation here. So hopefully you can try to understand it better, so you can go through the notes by your own after that. Okay, but basically what I'm explaining is basically explaining about your notes lah. Okay, so alright, when you look at these two graphs, right, I'm showing you what is the difference between a graph with different mean, a distribution with different mean, and also a distribution with different standard deviation. Okay, so when you look at this graph, right, so you can see that they have almost the same shape. So meaning like how the graph, how the distribution spread up is basically the same thing. Then I have like the roughly same peak also. Okay, but if I'm going to draw this on the timeline, right, then you'll realize that this will be at my right hand side of this graph. So the mean here is like 10, but the mean here is like 25. So this is how is that look like if a distribution have different mean but the same variance. So variance meaning like they tell you that what is the average distance from your mean, right? So you can see the variance actually tell you like how spread out your data is. So that's why if they are having the same standard deviation, meaning that the spread out of the data is roughly the same for these two distribution, but the difference is the mean here. So meaning like the mean here is like at 10 and the mean here is like 25. So okay, maybe I can give you an example. Like for example, if this one I'm talking about a weight of a baby that is like 1 year old, this is like the weight of the baby that is like 3 years old. So you can see, of course, in average, the weight for the 3 years old baby will be like much more heavier. So that's why they have a higher mean. But then the standard deviation is like roughly the same, because like the variation about the lightest or the heaviest baby is like roughly the same. So this is the idea of like different mean but same standard deviation. Okay, so for this second one, we are talking about same mean and then different standard deviation. So this is how the distribution will look like. So basically, I have these two distributions. So you can see the mean is the same, meaning like the single peak is for these two graphs are all at 10. Okay, so what is the difference here is like you can see that for the graph that I draw with the red color or the orange color here, the data is more spread out. Then for this one, they are more, the data spread is like more narrow. Okay, so you can see like for this one, definitely you have a standard deviation or the variance that is like higher than the first graph, because their data is more spread out, meaning your standard deviation is higher. So that's why this is how the graph look like when you have the same mean and different standard deviation. So we are talking about in this world, right? Actually, you can have all kind of like normal distribution created in different incident. But the idea is like, normally we cannot get a graph that give you a normal distribution which is standard, which is the mean is 0 and the variance is 1. So how are we going to do that to standardize all your normal distribution so that we can find your probability with the normal distribution table that we have? Okay, so now I'm going to explain how are you going to do that, because you can see that all the graph actually for all normal distribution, right, they have the same shape. They are symmetrical and the total area is 1, and no matter how I'm going to change it, like whether it's more spread out or it's like with different mean, I'm going to standardize it into a standard normal distribution. Then after that, I'm going to use the standard distribution to help me to find the answer for the other probability. Okay, so how are we going to do that? So I'm going to explain it with this idea. Okay, so you see, this is my standard normal distribution. Okay, so if you still remember in the second lesson, we say that like this is like roughly 68% of your distribution. Then after that, we go to like 95% and 98% and so on. So for a standard normal distribution, we have a mean of 0 and a standard deviation of 1. Sorry, and a variance of 1, or basically standard deviation is 1 also. Okay, so now let's look at this graph. Okay, so you see, this is like an easy example of maybe I'm doing a distribution of height of 18 years old boy. So why do we say that it's normal distribution? Because it satisfies the condition like it's a bell-shaped curve and it's symmetric, and they have a single peak in the middle also, and we have all the total area under that can be my probability. And then it also fit into the situation that this part is like 68% of my distribution and then 95% and so on. So this graph, when you look at this, right, the mean actually is 170. So if we say that this part actually consisted of 68% of your graph, then meaning that your variance, okay, like the mean is 170, right? Okay, so when we talk about the variance, then it's going to be like, this is the standard deviation here is like 1. So that's why the variance here is like 1 square. Okay, so if we look at this, then meaning that the standard deviation here from here to here is basically like 5. So how do we find the, so how do we find the variance? Is basically we will use 5 and then you will square it, correct? Then this is how you get to your answer. Okay, so this is a normal distribution sorry, I should use X here. Okay, normally we only use Z for standard to represent normal or standard normal distribution. So for a normal distribution, we use X as random variable. Okay, so X here actually represent my height. So the height of 18 years old boy is normally distributed with a mean of 170 and then with a variance of 5 square. Okay, so this is represented by this graph. Okay, my question now is, if I already know that this is a normal distribution, meaning that I can always change it to a standard normal distribution. So how am I going to change this graph to this graph? Okay, so first thing that we are going to do is, let's say, you can see, right, I have this graph at the mean of 170. So meaning what can I do? I can try to shift the whole graph horizontally. So I'm going to push it up a bit. Okay, so you see, I'm going to put the whole graph, like go to my left hand side. Yeah, okay, so you imagine I have all the number line here. I'm going to shift this graph horizontally, go to my left hand side until the mean reach 0. You get what I mean? So meaning now 170, I shift it to the line that is 0 here. Is that okay? So meaning then what happened to my 175? It will become 5. Correct? Because the distance is still the same. I'm just doing a horizontal shift. Okay? So the whole graph I'm like shifting to the right until the peak line here goes to 0. So I will have 0, 5, and then here become 10, 15. So the same thing, negative 5, and then negative 10, and this go to negative 15. So you can see what I am actually doing is like all the number here, I use it to minus the mean that I have. So meaning 170 minus 170, this is how I get 0. 175 minus 170, this is how I get to 5. 180 minus 170, this is how I get a 10. So what I do at the first one is I'm using all my random variable, all my data here, I minus my mean. So that's why I'm trying to shift it to my left hand side until the mean now already becomes 0. Okay, can you see this? Before that, the mean is at 170. After I do this step, after I shift it, right, what happened? My mean now already becomes 0. Okay, so after that, you see, is this same with the standard one? No, not yet. So what is the thing that you need to do now? So you see, you have the mean already. Okay, to get mean equals to 0. Okay, so now you are in a halfway. So you already get your mean as 0. But then now your standard deviation here is still a 5. So how are you going to change it to 10? So you can imagine you are going to stretch it. So stretch it like horizontally also. So instead of 0, 5, 10, 15, I'm going to stretch everything like divide everything by 5. So meaning that my 5, 10, 15, I'm going to change it into 1, 2, 3. Then after that is going to be negative 1, negative 2, and negative also 3 also. So you see what I'm trying to do here, after I use x minus mu, right, I'm going to divide it with my standard deviation. So my standard deviation here is 5. So 5 square here is because this is variance, so meaning my standard deviation is 5. So I actually divide my standard deviation then for me to get a standard deviation that is 1. So now you see this graph is basically the same thing like this. So I wish that you can try to imagine in your mind that for every normal distribution, actually what we can try to do, we shift the graph so that we get a mean of 0. Then after that, it's like normally you will have a data that's like much more spread out than a standard normal distribution. Then from a very stretched out graph, I'm going to stretch it to become a more narrow graph so that I get a standard deviation of 1. So you see this is like more spread out. Then after that I'm going to put everything like much more narrow so that my standard deviation now, like here, instead of a 5, now I change it to like a 1. But then I'm still going to get the exact same thing, like which this area give me like 68% of my data. Then this one is going to give me 68% as well as this one. Okay, so the idea of the whole process like this is basically called as standardization. So meaning, what are you trying to do? You are trying to make every normal distribution into a standard normal distribution. So you see, what is the process you do? You minus your mean, then after that you divide your standard deviation. So you remember the formula here. This will not be given in your exam, so that's why you please try to understand. But if you can't, then I mean, you can still remember, like it's not like very hard, right? Okay, so this is the formula that you will use to change any normal distribution with a random variable x into a standard normal distribution variable, which is z. Okay, so now, yeah, you can read through your notes here. Actually, I'm explaining the same thing but in a graphical way, so you can try to like understand it better. Okay, so but if you want to, then you can try to copy it in your notes as well. Okay, so now let's move on to like, then I try to write down so I try to write down a summary in your paper as well. So in short, for a distribution has a random variable, has a continuous random variable x that is normally distributed with a mean and a standard deviation, and a variance of sigma square, we can find the probability of x taking a range of values through calculate the z first, meaning you are going to do the standardization, then you are going to do the exactly same thing that you have learned in the last two lessons. Okay, so now we'll be using the step, or we are going to apply the skill in some examples. So I hope that you can try to understand everything. Alright. Okay, alright. So we are going into some example. So today we'll not be like using so much time in explaining like about how do you find the value in the table and why are you drawing positive, negative, and so on. So you should make sure that you already you already grab the idea of like the previous, for the last two lessons before you move on to this one, because you'll realize if not, then you are going to be like very confusing or like find it very difficult when you deal with like how do you find probability for z, because that is your basic. So if you not sure that you already know everything in the previous lesson, so make sure that you already finish all the homework and so on before you come to this lesson. Okay, so I will not like put so much time into like explaining how do you read the table and so on. So I'm just going to like explain some of the question, like because I think I didn't really explain in the video very well for the previous lesson for the critical value part. So some of the question I put in like some probability that you can actually get it here. So I hope that I can give you like a better idea here. But before we move on, I just want to say something about the table. Okay, if you realize that you can't get a certain value from the table, right, get the one that give you the nearest value. So meaning like if you can't find like 0.8414, then what you can try to do, just find 0.8415 like that. So try to find the nearest one. So if you have two value that actually give you like the same nearest value, then what you can do, just pick any one. So in the marking key, they won't be like so strict on this. Like if there is like more than one choices that you can make, right, actually every choices is correct. But then if you have something like you have like 5 choices that give you the exactly same value, then you can pick the middle one, that of course will be the best. But if you're trying to pick another one, then it's alright also, like everything will be acceptable if the situation like that come out in your exam. Okay, alright, so let's move on to the example. Okay, so example 1, the weight of male students in a certain school are distributed normally with mean 42 kg and a standard deviation of 5 kg. So you need to find the probability that a student selected randomly has weight less than 38 kg and so on. Okay, so for number 1, ABC actually is the question that I want to show you like what is modeling mean. So we just start with like very easy question first lah. So to let you understand like how do we use the thing that we learned just now. Okay, so number 1, so what you can try to do is I think it will be helpful that you try to write everything like in a way that you don't need to keep on reading the question. So for example, you already know that the data given in this question is basically the weight of the male students. So I'm going to start with this. So what is my X? My random variable here is the weight of male students. Okay, so I can understand that what is my X, then my variable here is the weight of the male students. That is my data. Okay, then after that, they are distributed normally, right? Meaning that I can write X is normally distributed. Then you still remember, after you write X, then it will be mu, then sigma square, meaning your mean and your standard deviation. Then you can put it in, your mean is 42, and your standard deviation is 5 square. Okay, standard deviation is 5, so variance is 5 square, so that's why 5 square. Okay, it's totally fine that you don't need to write 25 because when you try to do the calculation, you still need the standard deviation. There's no point that you want to like square, then after that you square root again. And I mean the question will not what is that called, penalize you if you write like 5 square because they didn't ask you to find variance, right? Okay, so this is like just a statement for you to understand the question. Okay, so find the probability that a student selected randomly has weight less than 38 kg. So you can start to do, what do you want to find? The probability, okay, for the weight of the students, which is your X, the probability for the weight of the students that is less than 38 kg. So this is basically what do you want to find. So you still remember this one is based on my normal distribution. So whenever I want to find probability, the first thing that I need to do is I need to standardize my normal distribution first. So the first thing I'm going to do is, sorry, I'm trying to write down here. Okay, is change my variable, random variable X into a standardized variable which is Z. So P probability Z smaller than, then this come our formula, so which is 38 minus our mean here 42 divided by standard deviation 5. Is that okay? So just follow Z equals to X minus mu divided by standard deviation. So I'm changing my random variable X into a standardized variable Z. So how do I standardize that? I use 38 to minus my mean, divide my standard deviation. Okay, then after that equals to PZ smaller than, then you can use your calculator to calculate that, negative 0.8. So you see now your probability is in a standard normal distribution form already. So because you are using the variable Z here, which is already standardized. So now what you can do, you can continue what you have learned in previous lessons. So find out in standard normal distribution, what is the variable that is lesser than negative 0.8. Okay, so I hope that by now maybe you can already imagine everything in your mind that you don't need to draw up. But if by now you still find it like very difficult, of course you can try to draw it beside. But I'm not going to do this in this paper because I assume that you should be able to get this idea already. Okay, so for probability Z smaller than negative 0.8, it will be equals to 1 minus probability Z smaller than 0.8. Okay, so if you are asking why doing so, then please try to draw it up, then you will understand. Okay, so after that, after I get this, then I get 1 minus 5, 0.8. Okay, so after reading from the table, then I should be able to get minus 0.7881, which will give me 0.2119. Okay, I hope that you are alright. Yeah. Okay, so let's move on to 2. the weight not less than 40. So not less than 40 means that is more than 40, correct? So probability for me to get a student whose weight is more than 40 kg. Okay, so it will be equals to, same thing, the first thing that I'm going to do is standardize my random variable. So changing my x into z. Then after that, I need to do 40 minus my mean, divide my standard deviation. Okay, so it will be equals to probability z greater than, so 40 minus 42, then after that divide by 5, I'm going to get negative 0.4. Okay, so for probability z greater than 0.4, you are going to do reflection, then it become less than already. So probability z less than 0.4. Okay, so now you can change it into 5. So 5, 0.4, they will give you an answer of 0.6554. Okay, so I hope that you are alright. Okay, so let's move on to 3. I'm sorry, this should be 3. Okay, between 38 kg and 45 kg. So the same thing, you are going to write what are you going to find first. Okay, so you want to find probability that your x is between 38 and 45. So meaning greater than 48, but then less than 45. So this is what is that mean by between. Okay, then you are going to do the same thing, standardize it. So probability 38 minus your mean, divide standard deviation, becomes z now because you already start to do the process. So 45 minus 42 over 5. Okay, so this one they will give you an answer for negative 0.8 z, then 0.6. Okay, so the same thing, by this step then you should be able to do, because it's like the same thing that you have learned in previous lesson. So meaning that for you to find this, then you have probability for z less than 0.6, and you are going to use this to minus the one that is like lesser than negative 0.8, which is 1 minus probability z smaller than 0.8. Okay, so after that it will become 5, 0.6 minus 1 plus 5, 0.8. So which will give you 0.7257 minus 1 plus 0.7881, which gives you the last answer 0.5138. Okay, so yeah, so basically the new thing that you are learning inside the front part. So like for the one that you already got your z and probability, actually you should be able to continue by your own already, so I'm not going to explain that. Okay, so let's move on to B. Find x if 80% of the students selected at random have a weight less than x kg. Okay, so this is like in lesson 2, you learn given probability, how do you find your z. So this one is like given probability, how do you find your x. So it's like plus 1 process also, which is like you find the standardized value, then after that you need to find the actual value in your random variable x. Okay, so how do you write that? Then you try to write down a statement that represents this sentence first. So 80% of the students selected at random have weight less than x kg. So it means that probability for me to get someone weight less than x will be equals to 0.8. Is that okay? 80% of the students selected at random have weight less than x kg. Basically meaning probability for me to find a student that has a weight less than x kg is 0.8. Okay, then I'm going to do the standardized process again. So probability big X smaller than x, then when I try to standardize, then I'll get probability z lesser than, then my small x minus my mean, divide by my standard deviation, which give me 0.8. Okay, So now you can try to draw this out. Okay, so this one maybe I can show you because I think it's important for you to know how to know that the x that you want to find is positive or negative. Okay, so now you look at this one. This one is 0.8. So how do you know that your x value is going to be positive or negative? So it's just the same thing like you learned in lesson 2. So if you are going to have this this normal distribution, right? If you want something that is less than and give you 0.8, is definitely on your positive side. Okay, because if you are going to draw it in your negative side, then they won't give you an answer that is greater than 0.5, which is 0.8 here. So meaning that you already know that this x should be a number that is greater than 42. Okay, so after that, then what are you trying to do? You do the same thing. Normally, how do you find your x? Then this is how you find, normally how do you find your z is the same thing that how do you find your x. Okay, so this one is a positive number. That means that I can actually straight away change it into 5 already. Okay, so 5 x minus 42 divided by 5. So it's the same thing. I'm going to find 0.8 from my table. So meaning that I'm going to find out 5 what give me 0.8. Okay, I hope that you can get what I'm doing now. Yeah, so basically this one is like you finding your probability, right? This one is like given the probability, then you want to find the z value, then after that your x value. So that's why you are going to find out what is the value in your table that give you a probability of 0.8. Okay, so from the table, the same thing, you can find it yourself, then you should be able to get 0.842. Okay, so after you have both sides 5 already, 5, then after that you can try to simplify them. So x minus 42 divided by 5 will give you an answer for 0.842. Okay, then after that you try to solve it, then you should be able to get x equals to 46.2 kg. Okay, so it's basically meaning that 80% of the students selected at random have a weight less than 46.2 kg. So which is correct. Then how do you check? It's like you know that the mean is at 42, so you can try to imagine like this. If this is my original normal distribution, right, I have a mean of 42 here. So I have a height here, a weight here, which is like 46.2. So which is like greater than 46, and after I shade it, then it's possible that this number give me like 80% of the students will be less than 46.2 kg. Okay, so let's move on to number 2. Okay, so let's move on to number 2. The length of a group of the height of the group of first year students in a college has a normal distribution with a mean of 170 cm and standard deviation of 12 cm. Students with height of more than 175 are classified as potential basketball player. Then after that, you need to find the probability of the student chosen randomly is a potential basketball player. Okay, so this one is still quite easy. Like it's just like very similar to your previous question. Okay, so you want to find the probability for the students to have a height that is more than 175. Okay, so okay, maybe you can write down first what is the x here mean. So the x here is your height, right? The height of the students, which is your random variable here. Okay, so the height here is normally distributed. Okay, it's normally distributed. Then after that, what is your mean? Your mean here is 170, and your standard deviation here is 12. Okay, so this is how you try to denote your information here. Okay, so find the probability of the students chosen randomly is a potential basketball player. So to be classified as a potential basketball player, the students must have a height of more than 175. So that's why probability for the height more than 175 is a probability that you want to find. Okay, so it will be equals to probability z greater than, then you put in 175 minus your mean, which is 170, divided by standard deviation is 12 here. Okay, so you try to use your calculator. So PZ will be greater than 0.417. Okay, so you remember every time when you standardize your value, right, you can try to get like to 3 decimal place, because your normal distribution table can read for 3 decimal place here. So like even you start with a 1 or 2, then you can have like 4 significant figure, because your standard normal distribution table allows you to read up to that accuracy. Okay, so PZ greater than 10 point, then now you can start to find your standard normal distribution already. So this one will be equals to 1 minus probability that you have Z lesser than 0.417. Okay, greater than you can't find, then you will find smaller than you, and you will use 1 minus. So 1 minus 5, 0.417. Then after that equals to 1 minus 0.6616, which will give you an answer of 0.3384. Okay, so that is for number 2A. So let's move on to B. If it is found out that 135 first year students from the college qualify as potential basketball player, find the total number of the first year students in the college. So you can see that in statistics, right, actually a lot of application, they like overlap with each other. So it's not like this topic is like independent and that topic is like independent. So they can like overlapping each other. So this one, right, you want to find the total, and you know that the number of the students that is more than 175 is like 135. So how are you going to find that? So if you still remember in the previous, I think in the first chapter, we learned that probability for A will be equals to number of A then divide by number of S. Okay, if you forgot already, then please check it back. So meaning like probability for you to get a boy is basically equals to number of boy divided by total number of students, like that. Okay, so you already have the probability for the height of the students more than 175. Then now you also given the number of the students have a height that is more than 175. Then you are using it to divide by number of total that you have. Okay, so number of total is what you want to find here. So probability for x greater than 175 is 0.3384. Okay, so it will be equals to, what is the number of the students having a height that is greater than more than 175 is 135. Okay, yeah, it's given in the question, right? So 135. So divided by NS, then you're going to use your calculator, then you should be able to get NS equals to, so remember this, we talk about total number, so you cannot have like 398.5 students, so you must make sure that you must round it into the nearest number. Okay, so 399 students, so this is the total. Okay, alright, C, out of the total that you have find out, 348 first year students have heights of more than kcm. Find the value of k. Okay, so this one, same thing, you need to try to write down what do you want to find that, then you slowly solve it. Okay, so 348 first year students have height more than k. So you remember every time when you do your standard deviation, when you want to solve from your normal distribution, right, you only can solve the probability. Then after that, you try to find out like the information that you need, like in a number. So you cannot find out like the probability equals to 348. So how do you find out this probability first? Okay, so you can try to write out first. Probability for you to get a students that have a height more than kcm is equals to, what is the percentage, or what is the probability? It's like 348 divided by your total. Is that okay? So like if we say that like out of 40 students, 20 of the first year students have height more than kcm, then you know that the probability is like 20 over 40. So it's like the same thing. So if I say that out of the total 348 has a height of more than kcm, meaning the probability is 348 divided by 399 lah. Okay, then after that, I'm trying to do the same thing, standardize my x. Okay, so probability for z greater than k minus what is my mean, 170 divided by standard deviation 12. It will give me my answer, so you can try to change it here, 0.8722. Is that alright? Okay, so you are writing for significant figure because in the table, the accuracy given by the table is like 4 significant figure. Okay, then after that, you can slowly change it. So pz greater than, so now you need to imagine your value z here, is that a positive value or a negative value? So you might want to draw it here. So you can try to imagine this is like more than, and you need an area that is more than half, so meaning that it will be at the negative part. Okay, so if you still remember, if you want to find this, then what do you need to do? If this is your z, then if you want to find it, then you will need to reflect it to z here, which your z will become negative z, correct? So this is what you need to do. So that's why it will become probability z smaller than, you need to negative your z, so you negative the whole thing here, negative k minus 170 divided by 12 equals to 0.8722. Is that okay? Because of this one, you need to reflect like normally when you want to find pz smaller than z, then you will need to find pz smaller, this is more than, you want to find pz greater than z, it will be equals to pz smaller than negative z. This is what you do. So it's the same thing, you try to negative the whole thing. You should be able to understand this part if you already know lesson 2 lah, okay? So after you get this, then now you can try to change it into phi already. So phi negative k minus 170 divided by 12, and then equals to, same thing, 0.8722. You need to get it from your table. Remember, this is probability. Then you want to read what is your z that give you this probability. So that's why you are reading inside out. Okay, so find 0.8722 from the table. Okay, then you will be getting 1.137. Okay, so since you have both sides in phi already, then you can try to eliminate that. So negative, okay, it will be equals to 1.137. Then you try to solve it. So remember, the negative is not negative for the denominator and the numerator. It's like if you want to put your negative follow 12, then it will be follow 12. So if you, okay, the idea is like this. I'll try to write it here. So when you have negative a over b is equals to either negative a over b or like a over negative b. So it cannot be like both side a and b negative, because negative, then you will eliminate, then it will become a positive already. Okay, so it depends on you whether you want to put the negative follow here or follow the denominator, but it's the same thing if you want to bring the negative to another side also. So, okay, so I'm just like explaining this so you won't feel it like confusing when you solve this. So I'm going to put it negative plus, it will be giving me 13.644. So my k will be equals to 156 in 3 significant figure. So cm. Okay, so that basically meaning that out of 399 students, 348 students have a height more than 156 cm. Okay, so when you look at the original normal distribution, then you realize that is correct because your mean is like 170. So like 156 is like on the left hand side of your mean. Then after that, more than, it will be like 0.8722, which is like very logical. Okay, alright, so let's move on for number 3. Okay, the mass of a newborn baby in a certain region is normally distributed with mean 3.35 kg and a variance of 0.0858. Estimate how many of 1,356 baby born last year has a mass of less than 3.5. Okay, so same thing, what you need to do is try to write down everything in a sentence first. So meaning, what is the random variable here? It's the mass of a newborn baby. So that's why you can try to write out x will be equals to mass. Okay, it's just something that you denote, so you do not need to like keep on repeating reading the question. So this is a normal distribution as well. Then it will be equals to, so what is your, so what is your x? What is your mean? Your mean is 3.35. Okay, then your variance. So you must make sure that this is your variance, then later when you try to do, you must make sure that you change it into your standard deviation. Okay, I think I did something wrong. Okay, I'm sorry, for number 2, right, here is 12 square. Okay, inside here it must be variance. Alright, yeah, please check it. So this is 12 square. So everything is correct, like, it's just that the first step I write wrong. Okay, so this is my variance, then later we are trying to find out the standard deviation. So estimate how many of blah blah, so meaning this is my total number, and I'm going to find what is the number of the baby that had a mass less than 3.5. So before I can do that, I must find my probability first. Okay, so now I will find my probability first. So the first thing that I need to do is I try to write everything in a sentence again. So I want to find probability for the baby to have a mass that is less than 3.5. Okay, then I try to standardize it. So z smaller than 3.5 minus my mean, then minus divide by my standard deviation. So remember, this is a variance, so when I want to find standard deviation, I will try to square root it. So 0.0858. Okay, so I'll use my calculator to find out the answer, so which will give me an answer of pz smaller than 0.512. Okay, so after I have this, then you should know that this one I should be able to straight away change it to 5 already. So 5 0.512. Okay, so I'll try to read from the table. 5 0.5, then 1, then 2. Okay, so I will get 0.96957. Okay, so how do I find the number? So the same thing, the probability formula. Okay, so probability x. So if you need, then you can try to write out. If you think that you are fine, then you actually do not need to write out this. Okay, so the probability for the baby to have a mass that is less than 3.5 is equals to the number of the baby had a mass less than 3.5 divided by the total that I have. Okay, so meaning it will be 0.6957 equals to number of baby that I want to find, then divide by what is my total baby here. I have 1,356. Okay, then after I solve it, then I should be able to get number of baby had a mass less than 3.5 kg will be equals to 4943. Okay, so the same thing, you can try to write this out first, like 943.37. So you know that this is number of baby, so you cannot like write in a decimal, so that's why it will be approximately equals to like 943 babies. Okay, so if you're scared that your answer is not accurate enough, so you try to write this first, then you try to note that you actually understand it, so that's why you are changing it into a rounded number. Alright, okay, so let's move on to number 4. A factory produces half-liter tins of oil. The volume of oil in a tin is normally distributed with mean 506.18 and standard deviation blah blah. So what is the percentage of the tin contain less than half a liter of oil? Okay, so the same thing, try to write down first the information given from the question. So you have a x here, the x here is your volume. Okay, because you talk about the volume of the oil, right? Then after that, what is the mean? So the mean here, so x is normally distributed with a mean of 506.18. So this is your standard deviation. So when you write that, make sure that you're going to square it. Okay, because this should be your variance. So what is the percentage of the tin contain less than half a liter of oil? So this one is basically the same thing lah. The probability for you to get a tin that has a volume less than half a liter. So a liter is 1000 liter. So half a liter meaning 500 milliliter. So X smaller than 500. Okay, so I'm going to do the same thing. Standardize it. So 500 minus 506.18 divided by 2.96. Okay, so same thing, use your calculator to solve this. Okay, so if you think you need to draw, then you can try to draw it. Sorry, this is negative. So if I want to find less than, then I will need 1 minus probability Z smaller than 2.088. So now I can change it to 5. Okay, so 1 minus 0.9816, which will give me 0.0184. So this question want the answer in percentage, so that's why it will be roughly equals to 0.84%. Alright, okay, so let's move on to B. Find the probability that exactly 1 out of 3 random selected tins contain less than half a liter of oil. So I'm not sure you can see this or not. This is basically binomial distribution. So you can see, right, actually all your statistics, they are like very related to each other, like interrelated. So you must make sure that you don't like memorize and then like memorize without understanding like why are you doing so, because like, okay, you see, for every past year question, right, actually I already selected out everything based on topic. So meaning I already try to determine and decide the topic for you. Then when you look at the question, then you will be like, we are learning binomial distribution, so that's why I'm going to use binomial distribution. But you need to imagine that in your exam, that everything will be in together. So you must have the ability of your you must have your own ability to differentiate like what is the distribution or what is the method that I'm going to use in this question and so on. So you must make sure that you can understand the concept and the idea behind it, so you know that like for this type of question I'm going to do this, for that type of question I'm going to do that, like that. Okay, so you see, like this is a normal distribution table question, but you see this actually involves binomial also, if you can realize that. Because I want to find exactly 3 out of the random selected tins contain less than half. So meaning that I have an outcome that is like less than half or like more than half. Then I have what is that called? I have a finite number of my trial, which is 3, and I want to get a number of success that is 1. So meaning for this one, then my X now become a binomial distribution. So if you remember binomial distribution, you have N and P. So what is the number of trial that you are going to do is like 3. So what is your probability to give you a success which is less than half a liter of oil is what you find in A. So which is 0.0184. Is that okay? So this is binomial because of you have finite number of trial, then after that you already have your success and failure, which is this is your success and your failure is that you don't get a tin that is less than half a liter of oil. Okay, then you have a finite number of success also, which is 1, that is the probability that you want to find. So probability for you to get 1 success out of 3 equals to, then you remember the formula, NCR. Okay, so number of trial, 1 success. So I'm going to write it here so you don't. Probability X equals to R equals to NCR PR Q N minus R. Okay, so probability for your success 0.0184 power 1. Then after that 1 minus 0. For me to find Q, I use 1 minus P. Okay, then 3 minus 1, I get 2. Okay, then you use your calculator. If you want, then you can write this out. Like, try to find out your Q lah. Okay, then after that you can move on to your answer, which is 0.0532. Okay, so this is your answer for this question, and it's basically a binomial distribution. Okay, so yeah, I hope that you can understand what are we doing. So if you have questions, then you can ask me again. All right, okay, so let's move on to number 5. In an examination, the marks are normally distributed with mean 60.7 and standard deviation of 12.3. A candidate needs a mark of at least 40 to pass. Approximately, what is the percentage of the candidate fail in your exam? Okay, so your random variable here, your continuous random variable here is the marks of the exam. Okay, so same thing. Is normally distributed as well. Then your mean is 60.7. What is your standard deviation? 12.3. So this invariant, so that's why I square it. Okay, so you want to find the percentage of the candidates fail in your exam. So at least 40 to pass. So meaning anything that is less than 40 give you fail. So that's why you can straight away probability X less than 40. Okay, so by all means, if you want to find in another way, it's also alright. So meaning that you, if you want, then you can find probability for you to get a candidate that pass. Then you use 1 minus the answer. You should be able to get the exactly same thing lah. So I mean, it's like very logical, right? Probability for X smaller than 40 is basically equals to 1 minus probability X greater than 40. Okay, so it will be equals to, then I will do the standardization. So Z smaller than 40 minus my mean and my standard deviation 12.3. Okay, then I'll continue with calculation. Then I'll be getting negative 1.683. Okay, so for me to get this, then I will need to, like, because it's at negative side, so I need to reflect. Then after that 1 minus. So 1 minus probability Z smaller than 1.683. Okay, so 1 minus 5, 0.683, which will give me 1 minus 0.9538. Okay, so I'll give 0.0462. So this one they want percentage, so roughly give me 4.62%. Okay, so this is how I get my answer. Alright, so go for B. Distinction are awarded to the best 10%. So what is the least mark candidate need to get a distinction? Okay, so same thing. You need to identify what the question wants first. So the distinction are awarded to the best 10. So meaning that they have like standard there. So meaning like more than how many marks, then only you can get a distinction. I mean, of course, like in logical, you don't think that like less than how many marks, then you have a distinction, right? So distinction are awarded to the best 10. So meaning that I can try to assign a variable first. Okay, so maybe I'll write that let K be the least mark. Okay, because this is what I want to find, right? So let K be the least mark. So meaning like probability for me to get a students that have a marks that is more than the least mark is how much? 10%. Do you get the idea? So like K is the least mark for me to get a distinction. So the distinction only awarded to the best 10. So meaning that the probability for a student to get a mark that is more than K will be like 10%, which is 0.10. Okay, then after that, I'm going to solve it. So probability X greater than K equals to 0.10. Then I'm going to do probability. I'm going to do standardization. So Z greater than K minus my mean, 60.7 divided by 12.3. Okay, so you can realize that this one 10%, right? So I'm going to get a K. So it's something like I already know that my K will be on the right hand side of my mean, because more than the number I have 10%, right? It cannot be like on the left hand side. Then when I do more than, then it's impossible for me to get 0.1. So if you want to solve this, then of course I can use like 1 minus and the other way, but do I have an easier case? Okay, what if I try to change it? If probability for me to get X, for me to get a students that have a marks higher than K is 10%, meaning that what is the percentage for students to get a mark that is less than K? It will be 90%. So meaning that if I do not want to like deal with like very serious situation, then what I'm trying to do is probability for me to get a students that is less than K marks is basically equals to 90%. Then by doing this one, then I can straight away change it to 5 already. But of course, if I don't want, then I do the normal one, then I get the same thing also lah. So the other way, if I don't want to do this, then I will be doing more than, so 1 minus probability Z smaller than this one. So you see, after I do this, I'm still going to get the exactly same thing like this also. Okay, because I'm going to move this over here, then I'm going to move 0.10 in front, then I'm going to 0.90 and the positive P as well. So it's basically the same thing. So depends on how do you want to go with. Okay, so I have this, and I know that my K is a number that is a positive number, or on the right hand side of my mean, then I'm going to straight away change it into 5. Okay, so 5 K minus 60.7 divided by 12.3 will give me 0.90, or I can straight away change my 5 here lah. Okay, so now I want to talk about this. So 0.90. So for this one, right, you can straight away use the critical value table that is given. So this is like some of the common value, or like the common probability that we want to find. So since you already see 0.90 is a probability, right, then you can straight away see here 0.90, then you don't need to find inside your table. So 0.90 give you 1.282, then you can straight away get the value here. So meaning for me to get a probability 0.90, the 5Z, the Z is basically equals to 1.282. So I do not really need to read it from the table. I can straight away get it from the critical value here. So this is what is that useful for here. Like they write down some of the important numbers, so you don't need to keep on referring to the big table. Okay, so by doing this, then now I can straight away solve it. So K minus 60.7 divided by 12.3 will be equals to 1.282. So after I solve it, I'll be able to get K equals to 76.5 in 3 significant figure. Okay, so the least mark can be like 0.5, then I'll just put it in like 3 significant figure lah. Okay, alright, so let's move on to C. Okay, so the list of passing candidates is published the day before the list of distinction. So what is the probability that a candidate who has passed will have got a distinction? Okay, so it's basically what is your sample space now. Okay, this is actually a conditional probability also. So I would like to like explain it in a way that every time when you do conditional probability, it's important for you to understand what the question wants rather than follow the formula. Because I realize like sometimes you get confused because it's like you only try to memorize the formula that I want to find intersection, then divide by the one that is given. But it's actually a very logical or like common sense thing. So you do not try to memorize the formula, but instead I will recommend you like to draw a Venn diagram or like to try to imagine the whole thing. Okay, so the list of the passing candidates is published the day before the list of distinction. What is the probability that a candidate who had passed will got a distinction? So meaning now my question is, what is your sample space? Are you trying to see all the candidate now? No, you are going to see the candidate who had passed only. So you see your sample space now actually become the candidate who had passed. So out of the candidate who had passed, you want to find out what is the probability for the candidate to have a distinction. So meaning that what are you finding is like probability for you to get, for the students to get a distinction given that they already passed. Okay, So if you try to memorize the formula, then you know that you want to find distinction, intersect, pass, and so on, right? Then sometimes you confuse yourself like whether you want to multiply or what. But you just try to imagine like this. So when you try to draw the Venn diagram, right, is this going to be like independent one? So my question is, when every time, okay, let's say I try to write this down. So you have this. Okay, this is the formula that you might memorize. Okay, so you see, so every time when you want to do this, right, you need to ask yourself this question. When you want to find intersection, then the first idea that come to your mind will sure be multiply. Like you will use the probability for distinction to multiply the probability for passing. Okay, so the question that you must ask yourself before you do multiplication is this: whether it's independent or not. The idea of whether it's independent or not is like whether you get a distinction, is that going to affect whether you pass or not? Or like whether you pass or not, is that going to affect the probability for you to get distinction? Okay, so the question goes like this. You can try to ask, if today okay, if today you are going to get your result, so your target is to get a distinction. Like in the first day, right, without the passing list, without the list of the passing candidates is published, you don't even know that you pass or not. So the probability for you to get distinction is like A. Okay, now after that, the first after some days, then the list of the passing candidate come up. Then now you are in the list, so meaning that you already know that you pass. So do you think that the probability, the chances for you to get distinction become higher now? Yes, because I already know that I passed. Like at least I already eliminated the chances for me to get fail. So if I don't even know that I pass or fail, how can I even hope that I get a distinction? So you see, this is not independent, and basically this one is very obvious, like for me to get a distinction or is pass. So meaning that if I already know that I pass, then I have a higher chance for me to get a distinction. If I don't even know that I pass or not, then the chances for me to get distinction will be lower because maybe I fail. But now I already know that I pass, so the chances for me to get distinction will become higher. So they are not independent, so you cannot do multiplication. So after that, what can you find out is you see that for me to get distinction, is that mean that I am going to pass? Correct, right? So how can I get a distinction without a pass? So this one is definitely not only intersection, it's going to be like a subset. So meaning like for me to get a distinction, I must be pass also. So the distinction and the pass, the intersection, when we talk about this, we talk about intersect, right? So the intersection between a distinction and a pass is basically all for distinction. You get the idea? Okay, if I'm going to draw it out, then you'll be like this. When we talk about intersection, you will be thinking something like this. Okay, so like this is distinction, and this is part, and this is my what is that called? My probability, right? So you see, is this Venn diagram correct? It's actually no, because when you are doing this, right, meaning that you are saying part of the distinction pass, right? Because you have this outside here, which is not inside the pass, right? Meaning that you say that maybe part of the students that get a distinction did not pass, only like part of the students getting distinction is going to pass. But that is not correct, because all of the distinction must get a pass. So this question is actually something like this. This is my pass, and some of the students that get a pass get a distinction. So what is the intersection now? It's basically only the distinction, because all the students that get a distinction is basically the students that had passed. So meaning that this will become probability for me to get a distinction divided by probability for me to get a pass. or it's basically by reading the question that you should be able to get the probability for a candidate who had passed have got a distinction. So meaning you are going to get probability of distinction divide by the probability of them getting a pass. So that's why this will be equals to, then the probability for you to get distinction is basically for here, for the 10%, right? So that's why it's going to be 0.1 divided by probability for you to get a pass. So for you to get a fail is this one. So that's why 1 minus 0.0462, which is probability for you to get a fail. So this one will give you an answer of 0.105. Okay? So I hope you can understand that, like, every time when you do this, the idea of asking yourself is what is the independent? Then it's like, is that independent? So if it's not independent, how am I going to find the intersection? Is that an intersection place, or is that like a intersect set, or is like a subset? So normally if like a subset, then meaning that actually like this case, then meaning that for like A, for sure B will happen also. Like for you to get a distinction, you must be passing. So that's why it's like out of the passing, then I have this distinction. So for me to get a pass and a distinction is basically the probability of distinction. Okay, so let's move on for the last two questions. Okay, so a machine, poor smelter, blah blah. Okay, you can try to read yourself. So I'm just trying to summarize please try to read it before you go on. Okay, so this question basically telling you a machine is going to like produce a bar of a chocolate. So like they have a label on the chocolate. So the company want to set the machine, like what is the mean that the bar of the chocolate should be produced. And after that, with the like minor error. Okay, the idea is like this, like when we talk about you want to produce a bar of chocolate, you cannot expect that if I'm going to write like 50 grams of the chocolate on the bar, right? Then I actually, in reality, I cannot expect everything that I produce from the machine will give me exactly like very accurate 0.50 gram. So the standard deviation here actually means like the error or like the small difference that will happen in like each of the chocolate. So like for this, right, so meaning that they want to set what is the mean that they should be set on the machine itself, so that they can try to reduce the error of the bar that is like the chocolate that they produce will not have 0.5% less than the weight that they desire to have. Okay, so that's why in this question, the same thing, you might need to try to write out first what is that mean by your random variable here. Okay, so the random variable here is you want to find for the weight for the chocolate. Okay, so this question they are asking you for the mean, then meaning that you do not have a mean here, so you need to find out the mean. So they already give you that they follow the normal distribution, so that's why the weight will be follow a normal distribution. But since you don't have the mean, then we can write the mean here. Okay, then after that, what is the standard deviation given? So it's 0.7. So for your variance is 0.7 square. Okay, so they want what is the requirement of the company. They want to produce a bar of 50 grams of the chocolate, and they want to have no more than 0.5% of the bar containing less than the contain less than the advertised weight. So meaning that they are assuming the probability for you to get a bar to have a weight that is less than 50 grams is not more than 0.5%, which is 0.005. Can you understand that? Okay, the companies want to have no more than 0.5% of bar containing less than the advertised weight. So meaning the probability for me to get a chocolate with weight less than 50 grams shouldn't be more than 0.5%, which is 0.005. Okay, so after that, you are going to solve that. So what is the mean that I should set on the machine? So when I produce it, I wouldn't get like more than 0.5% to have a weight that is less than 50 gram, which is what I advertise. Okay, then I'm going to standardize it as well. So probability Z lesser than, so 50. Then I don't have my mean, right? Then I'll write down my mean. So my standard deviation here is 0.7. Okay, lesser than 0.005. Okay, so after that, I'm going to continue. So you see now, this is lesser than 0.005. So do you assume that your value here, meaning your Z, is a positive value or negative value? Because that is going to affect how are you going to do next. So less than 0.05 and this is less than. So meaning that your standard deviation should be at here. So that's why this is how you get here like 0.005, and even you want less than that. Okay, so that's why if I'm finding this, then meaning that I should do 1 minus. Okay, so I'm going to do 1 minus probability for my Z smaller than, I'm going to reflect and I do 1 minus. So that's why negative 50 minus mean divided by 0.7 smaller than 0.005. Okay, is that all right? So I'm going to reflect, so I get this part, so I minus the lesser one. Then because I do the reflection, so that's why I'm changing a negative number to a positive, so I need to do negative. Okay, so by having this, then I can continue already. So I already have this one lesser than a positive number, so I can always change it into 5. So 5 negative 50 minus mu divided by 0.7. Okay, I'm like changing the whole thing to my right hand side, then this one go to my, so like this 0.958, sorry, 1 minus 0.005, so 995. Is that okay? This one minus, so I am putting this to my right hand side, so that's why like this become greater like that. Yeah, like max. If you can't, then you try to do it step by step. So basically I'm just changing this here, changing this here, so that's why my sign changed. Okay, so after that, then what I'm going to do, I'm changing 0.995 into 5. Okay, same thing, 0.995, I do not need to read it from the big table, I can straight away get it from the critical value here. So 0.995, which is 2.576, which is, I should be able to get it here. Okay, so 5, 2.576. Okay, then now with this, I can try to eliminate the 5 sign already. Greater than 2.576. Okay, then after that I'm going to continue. Minus 50 plus mu greater than 1.8032. Okay, then I'll solve for mu. So meaning that for me to get less than 0.5% of the bar, less than the advertised weight, I need to set the machine have a mean of more than 51.8032. Okay, the idea is that any mean that falls under this range can be accepted, but you wouldn't want to like set a very high range, like you want to set 60, then the company is going to like make like much more lesser profit, because like you are assuming that every of your machine is going to like produce in average the chocolate bar with a weight of 60, which is like very illogical, or like very I mean, no point to do that. Like, of course you will have a lesser bar that you have less than the advertised weight, but then for a company you would like to maximize the profit, right? So that's why the minimum mean that you must be set at is basically equals to minimum, or the least the least mean will be equals to 51.8. Okay, you want to have more than that, so 51.8, or even you put 51.9 also can. Yeah, because it's like more than, right? Okay, but this is like 0 point, so that's why it's totally fine lah, because it's like such a small number, because when I try to divide, then you like least, so that's why I can accept like equal to, yeah. Okay, all right, so let's move on to 7. So an airline does a survey of the weight of the adult passenger traveling on its flight. Find out that 5% of weight, blah blah, 2%, then assuming the weight normally distributed, you need to find the mean and standard deviation, meaning you need to find two variables. So you can assume that in this question they should be given you like two equations. So this is a simultaneous equation question. Okay, so you need to find out what is the mean and the variance. Okay, so same thing, you can write down the information given by the question, or you can try to assign what is your variable first. Okay, so same thing, you can put down your x. So the x here is the weight of the passenger, right? Then you can just write down weight. Okay, so it's normally distributed, but you want to find out the mean and the standard deviation, meaning that you are having a mu and sigma square. Okay, then after that, now you can try to write down the two information given by this question. 5% of the passenger weight more than 84.3 kg. What does that mean? Meaning that probability for you to get a passenger that has a weight that is more than 84.3 kg is equals to 0.05. Is that okay? 5% weight more than 84.3. So that's why probability for you to get a passenger that has a weight more than 84.3 is equals to 0.05 lah. Then the second information given is here, 2% for you to get a passenger weight less than 57.2. So probability to get a weight less than 57.2 is equals to 0.02. So now with these two equations, then you should be able to continue. Then after that, you need to solve each other. Okay, so how am I going to do that? Same thing, I'm going to standardize it first. So probability for me, z greater than 84.3 minus, I don't know my mean, then divide my standard deviation will be equals to 0.05. So after that, what is the normal thing that I'm going to do? The same thing. So my 0.05, I'm going to draw on my right hand side or my left hand side. This is more than, so that's why I know that the number that I'm going to put will be on my right hand side, which is 0.05. Okay, so that's why what I need to do is I will try to change it. So meaning instead of finding more than, then I'll find less than. So 1 minus probability z less than 84.3 minus mu divided by standard deviation equals to 0.05. Okay, then I'm going to what's that called, arrange it. So 84.3 minus mu divided by standard deviation will be equals to, so I'm changing here, changing this in front, so 0.95. So same thing, I can straight away read 0.95 from the critical value, so I do not need to find it in the table. So 84.3 minus mu divided by standard deviation will be equals to 1.645. Okay, so after I do this, then I'll be able to continue. So 84.3 minus mu divided by standard deviation will be equals to 1.645. Okay, I think after that I'm going to move this higher a bit. I scared I do not have enough space. Okay, then after that you are going to arrange this. So I will have like mu equals to this one multiply, and I try to rearrange everything, then I'll be able to get for the 84.3 minus 1.645 sigma. Okay, which this will become my first equation. Then I'm going to do the exactly same thing for this one. Okay, so probability z lesser than 57.2 minus mu divided by sigma equals to 0.02. So same thing, less than, then I get 0.02, meaning that I should be able to know that 57.2 is on my left hand side of my mean. Okay, so that's why I will need to do 1 minus as well. Okay, then I'm going to do reflection. Z less than negative 57.2 minus mu divided by standard deviation 0.02. Okay, I hope that you really can understand why I know that I should do 1 minus, or I do not need to do so. Okay, I'm just going to, like, just in case if you don't understand. I know that my mean is in the middle, so for this number, right, I will need to know the 84.3 is on my left hand side or my right hand side, so I know that what is my next process. So this is 0.05 and this is more than, so I should be able to know that I want to sketch here, so that's why my 84.3 should be here. So this is how I know that how should I continue. So this is the same thing. So this is less than and my mean is here. So my number is like 57.2. So for me to get like 0.02 and it's less than, it must be here. So that's why only I can get 0.02 here. Okay, I hope that you can understand what am I doing here. So this is why you need to do reflection. Then after that you do 1 minus less than. Okay, so after that I'm going to change it to 5 as well. Okay, so same thing here, I'll change to 0.98. Okay, so I don't think you can get this in critical table, so you need to get it from your big table there. Okay, so after you continue it, then you should be able to get in your table as 2.054. Okay, so now you have both already, then you can try to eliminate both of your 5. Alright, so I will get another one, which is mu equals to 2.054 sigma plus 47.22. Okay, so I think this part you should be able to continue already. So I'm just going to write very quickly. I do not have enough space as well. I'll try to move up a little bit, so hopefully you have enough space. And yeah, because I'm using actually I have enough space and when I do it with pen, but yeah, it's alright. Okay, so I'll use the second one to minus the first one. So this one should be able to give me an answer for 3.699 sigma equals to 27.1, which gives me sigma equals to 7.33. Okay, so after I get this answer, I'm going to substitute into the first equation, or if you want to use the second one, like depends on you. So times the sigma here, then I'll be able to get my mu is 72.2. Okay, so just like that, I hope that you can really understand everything and move on to your past year question and so on. So if you have any question, then feel free to ask me during consultation hour. Okay, alright, so that's it for today's lesson. Thanks for watching.